Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 5, Section 2, titled Relations and Functions. By the end of this video, you will have reviewed relations and functions. You will start by reviewing how to identify relations and functions by addressing the differences between them. Then you will look at evaluating functions. You will be looking at the function rule, evaluating the function rule, and finding the range of a function and thinking about the domain of functions. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. It'll help to be seen by many more students. Thank you. Okay, before we get started, let's look at a few definitions. A relation is a set of ordered pairs. You remember from past lessons, ordered pairs, the x, y pairs, for graphing, right? The x value and the y value, the ordered pairs, x1, y1 here, right here, x1, y1, and x2, y2, x3, y3. This is a set of ordered pairs. The ordered pairs are the x, comma, y value items. The range of this relation, we have a relation here, and the range of the relation is the set of second coordinates of the ordered pairs. So that is the y values, y1, y2, y3. Those are what we're going to think of as the outputs of our relation, or if it's a function, the outputs of the function. The domain of a relation, and this is a relation, is the set of first coordinates of the ordered pairs. So that's the x values, the x1, y1, y2, x1, x2, and x3. Those we will also call those the inputs to our relation or our function, whichever the relation happens to be. Okay, so what is a function? A function is a relation that assigns exactly one value in the range to each value of the domain. So if you have inputs A, B, and C, the outputs can only go to one number or value. They can't go to multiple values. Okay? And how do we know if something's a function? Well, we have a thing called a vertical line test. A vertical line test passes a vertical line, that's what it says here. If a vertical line passes through more than one point on the graph, the relation is not a function, and it fails the vertical line test. So what is that telling us? So let's see if we can draw a picture of it maybe. So if you had an coordinate system here, and you had a function that did something like this, a relation that did this, and here's your x values, right? And your y values. You can see here that this x value, which is say x0 perhaps, has a y value here and a y value up here. That means there are two inputs. So that would be the vertical line test. So at any time you draw a vertical line, if that line crosses more than two places or more than one place, it's not a function, it's only a relation. In order for it to be a function, it would be something like, if this is your graph, if it went like this, no matter where you drew your vertical line, it only hits one point on that line, on your function line, right? On your graph of your function. That's a function. The relation is more like this, where you see a coming back over the data, over the line, so you have 2 points, okay? So that's the vertical line test. If you put it, like say a pencil or something on your graph, it can only touch one spot. If it does, that's a function. A function rule is an equation that describes a function. So if they say write a function rule, they just say write an equation that describes whatever the state is that they're looking at. In function notation, you're going to start seeing this. A function is said to be in function notation when it uses f of x, the f parentheses x, close parentheses, to indicate the outputs. So you'll see it'll be written like this. F of x equals, let's say, 2x. There's a function. 2x is the function. and x is the input. That's your x numbers in your relationship here. And your y's are all these f of x numbers. These are your outputs. Okay? So you read f of x as just as I just read it. F of x. Right here. As I said, this was called it f of x. That's how it is. Or you could say f is a function of x. Okay, so we'll see this coming up again, and you'll see them. Okay, objective 1, identifying relations and functions. A relation is a set of ordered pairs. The age, comma, height, that's an ordered pair, or it's an ordered pair below. It forms a relation as it shows in this chart. Okay, so what do we have here? We start off here with 18 in the chart, and 18 is mapped to 4 1/4. So at 18 years of age, the giraffe was 4 1/4 meters tall. And then at 20 years of age, it was 4.4 meters. And then they have it in here at 21, it was at 5.25. At 14 years, it was 5. So they're not in order. So you couldn't really draw a very nice graph from them. But it's a set of ordered pairs. Every value, every input, all of these on the left are the domain. These are all domain. And all of these on the right are the range. Okay, so and in this chart, there's two 18s, and there are two different values, okay, for 18. And here, just to put that in the back of your mind right now, but you're going to see now that they put it into these ordered pairs, where they're the age, comma, height. So it's 18, comma, 4 1/4, right here, 20, comma, 440, 21, comma, 525, 14, comma, 5.00. These are meters on the end there. And at age 18, we had another giraffe, or how we got two values, or maybe this is the same giraffe, but at age 18, they measured it twice, and it grew a little over half an inch or a half a meter in that 1 year. So that's what we're getting out of here, okay? So it says the domain of a relation is the set of all coordinates of the ordered pairs. That's the coordinates, first coordinates, excuse me, all of the first coordinates of the ordered pairs. The range is the set of all second coordinates. Well, these are the first coordinates over here, the x values. These are the other values, the range, the y values, however you want to look at it. These are x values over here. These are y values there. You're going to see this come up quite often. Okay, let's move on. Okay, for example 1, it says finding domain and range. So we're just going to look at the same data we just looked at. And we talked about this on the previous slide. But now we're going to write it out a little more neatly, so to speak, right? It says, find the domain and range of the ordered pairs listed for the giraffe, data repeated to the right. Here, I repeated it. Here's the same data over here on the right. Okay, and notice here it says, list the pairs in order. Do not repeat values. Okay, list them in order. So here for the domain, I'm going to look at the first. The domain is the x input, the input, correct? The domain. So we have 14, 18, 20, and 21. That's what we have. We have two 18s, and we have a 20, 21, and a 14. So if we don't duplicate the 18s, so we have this, we start off with a 14, which is the lowest number here, and then we have the 18 and 20 and 21. So we've put them in order, okay? And now we're going to list the ranges. What are the ranges? Well, the ranges start at 4 1/4, goes to 440, goes to 885. That's in order, right? Okay, so for the 20, we have 885, 20. No, these are just in order. 4 1/4, 440, 485, 5, and 525. This is the range values. They're not mapping them to the domain values at this point. They're just listing them as range, as domain and range in order. And do not repeat the values. You won't see any number in the range values repeated. Okay? So for example 1, check your understanding. If you've been with me before, you know that this means to please stop the video, pause it, and do this on your own. And then when you start the video, we'll do it together. So I can wait for you. But what does it say? It says find the domain and range of the relation represented by the data in the table. That's it. Just all I want you to do is find the domain values and find the range values like we did in the previous slide. Okay, I'm waiting. Okay, I'm going to assume that you've completed that and you're back. So let's go ahead and do it. Find the domain and range of the relation represented in the data in the table. So what did it say in the previous slide? It says put them in order and do not repeat the values. So let's look at the domain. So domain. I'm going to put a parenthesis here. So what are the domain values? In order. So we have a -2 is the smallest. So I see a -2. And the domain, of course, they're even telling you what the domain is. It's this one right here. Then -1. And there are two -1s, but we're only going to write at one time. So comma, -1, comma. And then there's two twos, 1, 2, two fours. So then we have a 4. That's the domain. What's the range? Range. Okay, the range values are, the lowest is a -2, comma. And then we go from a -2, the next one in order would be a 1, and there are two 1s, but we only list the 1 one time. And then there are two 3s, and we only list the 3 one time. So there it is. So here's your answer. The domain values are -2, -1, and 4, and the range values are -2, 1, and 3. Okay, objective 1. Again, this is another slide from our objective slides. This is the second one. It's 1B. Identifying relations and functions, right? So the definition of a function is a relation that assigns exactly one value in the range to each value in the domain. Okay, so you can have multiple domain items pointing to the same range, but you can only have one range item pointing back to a domain. So the way you can tell whether a relation is a function is to analyze the graph of the relation using the vertical line test. If a vertical line passes through more than one point of the graph, the relation is not a function. Now, I beg you to remember this, because you will see this on tests as you move forward. When you're studying this, you will see this. They're going to ask you, well, is this a function or is this a relation? And you might get maybe one or two problems like that. You never know how many you'll get, but pay attention to this, okay? So again, one way you can tell whether a relation is a function is to analyze the graph of the relation using the vertical line test. And we'll look at it in the next slide, I think. If any vertical line passes through more than one point of the graph, the relation is not a function. So let's go look at that. Okay, example 2, using the vertical line test, right? So it says determine whether the relation, so there's 5 values here, 5 sets, 5 ordered pairs in this set. 5 sets of ordered pairs in this domain and range, okay? So we have 3, 0, -2, 1, 0, -1, -3, 2, and 3, 2. Those are our ordered pairs. So we graph them out. We just take each one at a time. So where is 3, 0? 3, 0 is, here's 3. X is first value, 3, and y is 0. So this is right here is 3, 0. The next one is -2, 1. So we go down here to -2 and go up to 1. There's the -2, 1 right there. How about 0, -1? 0 is right here in the middle, down 1, -1. There's that one. And -3, 2. -3 is here, up 2. Here's -3, 2. And finally, you have 3, 2. So go all the way back up here to 3 and go up here to 2. Okay, so now we have it graphed, the spots graphed out. So now you take your pencil, you do this. You can use a pencil, you can use the edge of your ruler. a piece of paper, it doesn't matter as long as it's a straight line. So what they're doing is using your pencil. So you put your pencil on the paper and you start sliding it from left to right. Doesn't matter which direction, but slide it horizontally across the page. And as pass the pencil across the graph as shown. Okay, from this point from here, slide it. Just keep sliding it. Keep moving it. Okay. So what are you going to see? You're going to see that the pencil starts way over here, and then you're going to come along the line. The pencil is going to cross one dot. Does not tell you right now so far this relation is a function in your mind. You go up for, oh, here's another dot. Well, there's only one dot touching the pencil. Go a little further, they're showing you that the pencil's still moving. Then you get over here to this where the zero on the X line is, right? And there's only one dot that pencil can cover. Then you go all the way over here to 2 and nothing, and 3, boom. You get to X equals 3, and you get right here Y equals 0, and you get X equals 3 and Y equals 2. So that pencil right here, this pencil right now is going to cross those two dots at the same time. That means this is not a function because it crossed more than one dot. It could cross 3 or 10 dots. It doesn't matter. It's not a function. If it had stopped before that, you would have said that it's a function and not included those values right there, the X value of 3 and Y of 0 and or 2. Okay, so the vertical line test would pass through those 2 points and it would fail the vertical line test. Okay, example 2, check your understanding. As you know now that I'd like you to pause the video and try this yourself, but let's talk about it before you go. Use a vertical line test to determine whether each relation is a function. So I'm going to suggest draw a little graph and plot out the points. Try to be as accurate as you can so that you can see if 2 or more points align underneath that pencil that you're going to try as your test instrument. So go ahead and I'll wait for you. Okay, I'm assuming you've done that. So let's go to A. So I'm going to start off. I'm going to go, I don't know what it's going to look like, but let's draw a line down here and a line across here. And of course, there's arrows at the top, but you're going to find as you watch my videos that I'm not very, very good at writing in terms of clearly or drawing, but I do my best. Okay, so what are the X values? So all the X values are the first value in these pairs, right? So we go down to we're 4, a 1, a 0, and a -2. So we know we're going to be 2 down here. We're -2, 1, 2, and we're going to go up to 4. So I'm going to do trying to keep them the same size. 1, 2, 3, and 4. So here's 4. Okay, I don't need to put the other numbers in. You can do them on your own. So then we go from -2 to 2 to 1 to 2. So -2 goes down here, -2, -1, -2. Here's -2. We get a 1 and a 2 and a 2. So now we have a 1 and a 2. Okay, so what are so 4 x 4 and y -2. So that's this one right down here. Okay, then we have 1 and 2. So here's x1, y is equal to 2. Then we have 0 and 1, 0 and 1 right here. X is 0, y is 1. And then we have -2 and 2. -2 and 2 is right here. Okay, so now you got this point here, a point here, a point here. I'll draw this a little bigger, and a point way over here. So now if you take your pencil and draw it across the page, you're going to start imagining lines coming down, right? So if you've done that, you see that there's only one dot that a line would hit right here. This is on the y-axis, and there's only one point on the y-axis, so that's only one point crossed by a straight line. Here's this one here where it's x is 1, y is 2. There's only one dot in this section right through here, right? There's only one dot. And then way up here, there's the 4, -2. Then there's still only one dot, right? So this is a function. Okay, at no time does a line cross through 2 points or two or more points. Let's do B. I'm going to draw the same thing. I'll draw, okay, and they have arrows. They go forever, unless you're told that they don't. And so what do we have for x values? We have a 0 and we have a 2. So I'm going to say 2. Let's do this x's first to see how big the graph has to be. 0, 1 is going up 1, back 1, it's at -1, back at 0, and it's 2. So it goes 2, 1, 2, and 0, -1, and -2. It's as far as it goes, and in fact, it doesn't even go to -2. And then for the y's, we have 1 for sure, 2 up there. We have a -1 down here. I'm trying to draw them so the lines are about even. And we have a 4, so 1, 2, 3, 4 way up there. We have a -3. We have a 1, a 2, and a -3. -3 down here looks the lowest. And then we have a 1 right here. Here's 1. So we have a 4 way up here. We have a 1. We have a 0. I'll just put a dot there, right? So that's 0. And we have 2, which is up here again. Here's a 2. I don't have to draw. I'll just write that there. And, excuse me. Duh, I'm getting confused. So let's start from the beginning. So we have a 0, and I'm going to write them out. 0, 2. 0, 2 is this one right here. Okay. Then we have 1, -1. So we go +1, -1 right here. Here's another one. Maybe it'd be better if I colored them in red. Would you like that? If I did that, red there, it might be better for us. And then we have a -1, 4. Here's -1 for the x, and 4 is way up here. And then we have 0, 3. Here's 0, and here's 3. Oh, -3, excuse me. 0 and -3, and 2 and 1. So right here. So now if we take our pencil and we start coming across, right, you're going to start moving it this way and slide it. Does it ever touch more than one dot at a time? Well, when we get to this dot, there's no other dot here. But guess what? When we get to x equals 0 right there, it's going to touch this dot and it's going to touch this dot. So that means it's not a function. It's just a relation. It's just a relation. It touched two dots vertically. Okay? Okay, objective 1C. Here's the third slide in our objective 1, identifying relations and functions. Another way you can tell a relation is a function is by making a mapping diagram. List the domain values and the range values in order. Draw arrows from the domain values to the range values. Seems pretty straightforward, right? So what would you do? You'd have something, I'll just make a quick little diagram. So you'd have something like, let's just draw a box. And I don't know how many values we're going to need, but I'm just going to draw some values, some lines. So you might have 1, 2, 3, and 4 as your inputs. And your outputs, then these would be the domain, and the range would be here. And then on the outputs, let's say the function is x plus 1. Well, then the range values are going to be 2, 3, 4, and 5. Well, okay, so what they're going to ask you to do is open this up and make this so that you can draw arrows. So you're going to have a bigger box like this. Let's have a box, right? On this side, you're going to have 1, 2, 3, 4. On this side, you're going to have 2, 3, 4, and 5. And you're going to draw an arrow. You're going to say 1's going to go to 2, 2 is going to go to 3. And what if it changed? It could have been something different too. It could have, see, these are all going, we're showing you where they're going. What would happen if this 2 went to this 2? Okay, let me do that. I'm going to erase it. I'm going to erase this and erase this. I'm going to put the 2 back, the 3 back. And I could have drawn up here. I could add 1 go to a 2, and I could add 2 go to a 2. It's possible it wouldn't be this function, would not be that function, but it still would be a function. Okay, so that's what it shows. Draw the arrows from the domain values to the range values. So you take whatever the value in the table from the domain and just hook it up with a range value. So let's see how that works out. Okay, example 3, using a mapping diagram. So that you see the sets of ordered pairs. There are 4 of them in the first set. 1, 2, 4 ordered pairs in each set. Okay, and they're showing you domain and range, little tables here. So they've taken the numbers. They have 11, 12, 13, and 20. They put them in order, listed them from least to greatest. So 11, they start with 11, 12, oh, they're already in order here, 13. And then they, in this side, they put these in order, -2, -1, 7, -2, -1, and 7. They're in order. And now they show you how they map. 11 went to -2, 12 went to -1, 13 went to -2, okay, 20 went to 7, okay. Then B, so what is this a function or not? According to what we see here, this is a function because at no time does any one member of the domain go to more than one value in the range. Now we're going to probably see the difference, okay? So in B, we have -2, -1, -1, 0, 6, 3, -2, 1. We put them in order. First of all, we're going to eliminate 1 because it's going to be kind of obvious that there are 2 -2s, and we're only going to use 1 in the chart. So we're going to have that, and it's the least value. So we're going to have -1. Then we're going to have the next one in order is going to be -2. Then the next one in order is going to be -1. And then finally, the last value in the domain is going to be 6. And as far as the range goes, we have a -1, a 0, a 3, and a 1. So we have there are no matches doubled up or anything, right? So we're going to start with the least, which is -1. Here's -1. Then it goes to a 0 here for 0 in order. And then another 1, a 1 now. We put the 1 in here. And then finally a 3. Here's the 3. So now when we draw the lines, what do you get? You get -2. -2 goes to -1. And it also goes to 1. Okay? -1 only goes to 0, and 6 only goes to 3. But since you have 2, which is a domain item going to 2 or more, in this case 2 or more range values, you have a relation. It is not a function. Okay? So just keep that in mind. You're going to be seeing this guaranteed on tests in the future. Maybe more than one test. Maybe on some final exam somewhere. I've seen final exams, that question, or how to tell, is this a function or is this a relation? It always comes up. Okay, example 3, check your understanding. Using a mapping diagram to determine whether each relation is a function. Okay, so they want us to use a mapping diagram just like we did on the previous page. And then tell whether it's a function or a relation. So let's go ahead and do that. First, this is a check your understanding, so you're going to go ahead and pause and then try them. And then when you come back, we'll work them together. Okay, I'll wait for you. Okay, let's assume you've done that. We're all excited and ready to get going. So the first thing I'm going to do is I'm going to draw the little box, at least an open bottom box, because I don't know how many values are going to go in there. So I'll leave it like this. And we're going to look at A. So we get 3 for the x values in the A problem. So we have a 3, an 8, and 9. So those are going up. A 3 again, and a -4. So the x value with the least value, or the x x term with the least value is -4. And then we have the 3. So a 3, and then the next is the 8, and then coming after that are the 9. So that finishes that. I'll draw a box over here. leaving the bottom open. And over here I have a -2. Is there something less than -2? Yes. No. -2 is the least. -2. So then a -2, I have a 0, 0, and then I have a 1, a 2, and a 3. 1, 2, and 3. Okay, so now we have to looking back at the pairs, draw lines from the x to its y value. So 3 goes to -2. So 3 goes to -2. Okay, 8 goes to 1. 8 goes to 1. We have 9 going to 2. 9 goes to 2. We have -4. Oh, wait. We have 3 going to 3. We have 3 going to 3. And we have -4 going to 0. Okay, so now if you look at that, what's the key? We're looking on the inputs, on the domain side. In this type of a diagram, we're looking for two lines coming from any one number. And the fact that we have that, that says that the 3 value, that a 3 in will give you either a -2 or a +2 as your output. Okay, which you could have that in a relationship, but you cannot have it in a function. So it is not a function. Okay, let's try it over here on B. I'm going to draw our domain side. Domain side. Okay, and we have there's a decimal point in here, so it don't matter. We're still going to fit it in order. So 6, here's a 6 is below that, so we know he's going to come first. Here's a 2. So I have a 7, a 6, a 2, and a 5, so the 2 is first. Oh, yes, 2. 2's first. Then from 2, we have a 5, 6, 7, 6.5. So it's 2 goes to 5, 6, 6.5, and what was it, 7? Yeah. 5 values, 5, 1, 2, 3, 4, 5 pairs. Now we'll draw our box over here. The lines aren't very straight, but I've joked about this before. My drawing on this tablet is, I wish I would be better, but it's just not that good. Drawing and writing. Hopefully you can bear with me. Please forgive my inability to make this look much better. So now we have the range values. The range values, we have a 0 here. We have, oh, where'd my pencil go? We have a 0. We have a -1. That's lower than 0. Or yes. Here's a -1, 6, 2. So we're going to start with -1. And just above the -1 is 0. Okay. And then we have a 2, 2, what? A 0, a -1, a 2. Oh, two -1s. We don't put them in twice. Okay, so then we have the 0. We have a 2. And we have the 6. Right, so we have a -1 right here. And 1 right there. That means there's 1, 2, 3, 4 outputs. Here we have them right here. 4. And so here's the 0, 2, and 6. Okay, so now we should go back to our inputs, our set, our ordered pairs in our set, and look at 6.5 connects to 0. 6.5 go to 0, 7 goes to -1, 7 goes from way down here to way up here to -1, 6 goes to 2, here's our 6, and it goes over here to 2. And we have a 2 going to 6. Here's a 2 from way up here going way down to the bottom over here at the 6. And then finally we have our 5 traveling to -1, which is up here. Okay, so is this a function? Well, at no time are there two lines coming from any one of the inputs. So right off the bat, it does not matter how many times a value is used on the range side. See, as you see here, the negative 1 is used twice. 5 goes to negative 1 and 7 goes to negative 1. Okay? But there are no inputs that have two lines coming from. So this is a function. It is. Yes. Okay? Okay, objective 2, evaluating functions. So let's look at this. A function rule is an equation that describes a function. You can think of a function rule as an input-output machine. Okay? So here we'll look at this picture. We see a set of inputs, our domain values coming in. I'm going to maybe change this to a darker blue. Let's see how that looks. That's better. So these are our inputs coming in, inputs going dumping down the tube here. They get crunched around in this machine in here, this function rule, which is defined by an equation. And then we get our outputs. So the range is a set of output values. So it says, if right here, if you know the input values, you can use a function rule to find the output values. Well, okay. The output values depend on the input values. So what do we have here? We have an equation. Y is equal to 3x plus 4. Okay? Y is the output, and the input value is this x value right there. X is the input. But the equation, the function rule says take that x value, multiply it by 3, and then add 4. That's what you have here. The input values for x go in. They get crunched through that equation, 3x plus 4, and you get an output value for y. And if you look at some of these input values for x and y, output values for y, if you put a 1 in, let's go back to the equation right here, 3x plus 4. If you put the 1 in for the x, you get 3 times 1, and that's equal to 3. And then you add 4 to it, and what do you get? You get 7. And that's the output value, 7. Same thing, if you put a 2 in for the x, you're going to get 3 times 2 is 6, plus 4 is 10. Or if you put a 3 in, 3 times 3 is 9, plus 4 is 13. Another way to write a function, y is equal to 3x plus 4, is f of x. F parenthesis x parenthesis, right? Open paren, close paren, equals 3x plus 4. A function rule is a function, a function rule is in function notation when you use f of x. And that's pronounced f of x right here, this little bit right here, f of x, to indicate the outputs. So you read this f of x just as I'm reading it to you now as f of x, or f is a function of, over here, function of x, okay? So the notation g of x and h of x also indicate functions of x because the x is right here inside the parentheses. So they're saying this is a function. It could be any letter you want here, something of x. Could have been, it doesn't have to be x either. Could be some other value, but in our case, we're calling it x. Okay? Okay, example 4, evaluating a function rule. So now we're going to talk about evaluate. We just did evaluate one in that little diagram, but we're going to do a couple of them here. Okay, problem A. Evaluate f of n. Remember, I said it doesn't have to be f of x. It could be any letter you want. So in our case, our function has negative minus 3n. Right there's the n, minus 3n minus 10. Negative 3n minus 10 for n equals 6. So this is now f of n, because that's the variable. We're taking the function. Function of f of n, or f is a function of n. Okay, so now we're going to substitute. For the n, they want us to substitute a 6. So we're going to do that. And we can, everywhere there's an x, we can write 6 now. So we're going to say f of 6. We want to find this function for just that value. We want to find, given this input, we want that output for that 6. So it's negative 3 times 6 minus 10. So we substitute the 6 for the n, and then we solve it. So f of 6, and you say it just like that, f of 6 equals 18, negative 18. Negative 3 times 6 is negative 18 minus 10. Simplify and multiplication here. And what do you get? F of 6 is equal to negative 28. Negative 18 minus 10 is negative 28. Let's do B. Evaluate y equals negative 2x squared plus 7 for x equal to negative 4. So we're going to go over here. Now there's no f of x. It's just y. So we're just going to have to substitute the x value in the equation itself right there, the x value. So what is it? Y is equal to negative 2 times negative 4 squared plus 7. We're going to substitute a negative 4 for the x. And I put the parentheses around here because if you didn't have the parentheses, then that negative sign would not be included with the squaring. So you're squaring everything within. So when you square the negative sign, you get a positive sign. But if that was left outside, you'd have 16, but then it'd be negative 16. Okay? So we substitute parenthesis here, negative 4, in the equation. And when we simplify the power, we get y is equal to negative 2 times 16, because negative 4 squared is 16 plus 7. Now we're going to simplify multiplication. Negative 2 times 16 is negative 32. And you're going to add 7. And then you're going to end up with y is equal to negative 25. Okay, example 4, check your understanding. So evaluate each function rule for x equals 2.1. It'll make it a little more difficult for you, but it's just a matter of multiplication. You know, going to have a x squared in here, I see, and just a regular x. You'll figure it out. Use your calculator if you have to, if you must. Okay? Evaluate each function rule for x equals 2.1. So I'm going to pause the video, or you're going to pause the video. I'm going to wait while you pause it. And then when you get back, we will do them together, okay? Okay, check your understanding. Right? So we're going to go ahead and say that we have evaluate each function rule for 2.1. Starting with A, we're going to substitute in, we have y equals 2 times x, and x is going to be replaced with 2.1. And then add 1. And when we do that, we're going to replace the x with 2.1 right here, and we're going to multiply this out as 2 times 2.1, and it's plus 1. And when you do that, you're going to get 5.2, because 2.2 times 2.1 is 4.2. 4.2 plus 1. Okay? How about doing the next one? B, f of x. Okay, now we have this. Okay, is x squared minus 4. Well, this is nice because now you're going to say, I'm going to do the function of 2.1. So I have f of 2.1, that specific value. Okay, and when we square that, you're going to get you're going to square the 2.1, you're going to get 4.41. 4.41, okay? And then you're going to subtract 4 from that, and you're going to end up with 0.41 right here. Because 2.1 squared is 4.41, and then you're going to subtract 4, and you're going to get 0.41. And then finally you have g of x, no longer f of x, doesn't make a darn bit of difference. G of x, q of x, L of x, it doesn't matter. Your x is your input, and the g here in this case just says we're going to call our y values g values, okay? G of x values. So we're going to replace the x with 2.1, and that is g of 2.1 is equal to 2.1 plus 2. And what is 2.1 plus 2? 4.1. Okay, example 5, finding the range. So what we're going to do here is we're going to get a set of domain values, and then we're going to plug them into our equation, our function rule, and we're going to end up getting the range values, okay, as a set. So let's look at this. Evaluate the function rule f of a, so a is our variable, equal to minus 3a, or negative 3a, plus 5, to find the range of the function for the domain. And they're telling us they want us to use values negative 3 1, and 4 are the three domain values they want us to put into our function rule and then come up with the domain values for it, okay? So the first one we're going to do is we're going to take the negative 3 value. And you're going to put that in, and you're going to get f of a is equal to negative 3a plus 5. You're going to substitute the a. Negative, in both cases, you're going to substitute the a. F of negative 3 is equal to negative 3 times negative 3. I put the parentheses around here just so that you know that that's, okay? That is your a value, the negative 3. I put that, makes it very clear. And mathematically, it makes more sense. And then plus 5. So negative 3 times negative 3 is 9, plus 5 is 14. F of negative 3 is 14. Now let's do it for the second term, and the second term is 1. Right there, 1. F of a is equal to negative 3a plus 5, same function rule. And we're going to say now f of 1, because that's our value, our domain that we're putting in. So we want to find the function value when when the domain is 1. Negative 3 times 1 is negative 3 plus 5 is 2. So f of 1 is equal to 2. Now we're going to do the last one, and that is a 4. So f of a is equal to negative 3a plus 5. F of 4 is equal to negative 3 times 4 plus 5. And when negative 3 times 4 is negative 12, when you add 5, you get negative 7. So f of 4 is negative 7. So what are the range values? So we have our domain values right here. The range values are way down here. We collected them. The first value is 14, 2, and 7. So if you were going to write them as pairs, how would you write them as pairs, right? You'd say negative 3 comma 14, and then you would say 1, 2. You're going to say 1 comma 2, and then there's a print there, and then you close that, and you get a negative 7 here and a 4 here, and then it'd be 4 comma negative 7, and your whole set of inputs would be these braces on here, and there you have it. Now you've seen it written in the different ways. Okay, example 5, check your understanding. So here they want us to do what we just did on the previous slide. They've given us 3 domain values, and they want you to find the range values. The interesting thing here is that it's 3 different problems. So you're going to have to do each problem 3 times, right? So you're going to get the same domain, and these are different function rules. A is its own function rule, B is a function rule, C is a function rule. The easy thing here is, hopefully the easy thing is when you're writing it out, because there's not a lot of room to do this, right? The function rules are pretty simple, so you can do them in your head and come up with the answer, and it should work pretty good. So I'm going to pause the video and let you try these, and when you get back, we'll do them together, okay? I'll wait. Okay, so find the range of each function for the domain. We have negative 2, 0, and 5, and we want the range values, okay? So there are 3 problems, and you're going to substitute in problem A, you're going to substitute the negative 2, 0, and 5. In B, you're going to substitute the same negative as negative 2, 0, and 5. And then in C, you're going to do the negative 2, 0, and 5. You're going to get 3 different sets, okay, as you complete this. So let's take a look at it. It's what we did here is we substituted in the very first one, f of x equals x minus 6. We substitute for the f of x, negative 2, over here on the left, right? So now we say f of negative 2 is equal to negative 2 minus 6. That equals negative 8. Okay, if you want to follow it all the way through, and down in the range values, I put in the negative 8 value. But we're going to, the negative 8 value, I'll wait. I'm going to say no. I shouldn't do that. I did it because I know how it's going to work out. However, I'm going to change that. I'm not going to do that because these are in order. And as I told you, you put the values in order. So these range values, they're range values. They're not ordered pairs. They're range values at this time. So -8, -6, and -1 are in order, not by order of completion, okay? So then we have f of 0 is 0, minus 6 is minus 6, and f of 5 is 5 minus 6 is -1. So now when we put these in order, we have -8, -6, and -1. That they are least to greatest in order. So f of x equals -4r. So f of -2 is our first value. -2 is equal to -4 times -2 is equal to 8. Then we have 0. F of 0 is equal to -4 times 0 is 0. Right here, 0. And f of 5 is -4 times 5 is -20. But in this case, they're going to be out of order, right? Because the -20 is the least. We solved them 8, 0, and -20, but from least to greatest, it's 20, 0, and 8. They've kind of changed positions. So it's 20, -20, 0, and 8. Okay, so now finally f of x is equal to r squared plus 1. So f of -2 is -2 squared plus 1, and that equals 5, because -2 squared is 4 plus 1 is 5. How about f of 0? So 0 squared plus 1 is 1, because 0 squared is 0. Okay, and then finally f of 5 is equal to 5 squared, 25, plus 1 is equal to 26. And in order, 1, 5, 26. So these are not in the order that they were solved. They're in the order from least to greatest. Okay? These are not ordered pairs. You can't make ordered pairs directly out of these because they might be out of order. Okay? So they're just domain and range is all we're talking about here.